The following data show the price in dollars, which is X, and the overall score, which is Y, for 6 stereo headphones that were tested by Consumer Reports. The overall score is based on sound quality and effectiveness of ambient noise reduction. Scores range from 0 to 100. The estimated regression equation for these data is y hat equals 23.194 plus 0.318 times X. Here's a scatter plot of the data together with that estimated regression line superimposed. Compute the sum of squares due to error, the total sum of squares, and the sum of squares due to regression. So first of all, the sum of squares due to error, and that represents the sum of the squares of the vertical distances between the points and the regression line. Next, the sum of squares, the total sum of squares. And if we add a horizontal line to our scatter plot at the value, at the mean value for the y variable, so the mean score is 55 in this data set, and so I've added a horizontal line at score equal 55, and the total sum of squares represents the sum of the squares of the vertical distances between the points and that mean line at score equal 55. Then the sum of squares due to regression is simply the difference between the total sum of squares and the sum of squares due to error. And the coefficient of determination r squared is the ratio of the sum of squares due to regression and the total sum of squares. That comes to 0.84 in this case. So 84% of the variation in scores can be explained by this simple linear regression model using price. And then if we take the square root of r squared, and if we take the positive square root in this case, because we've got a positive linear relationship between the two variables, then we obtain the correlation coefficient, which comes to 0.917.